Most of you must have seen ramp in your real life, and in this lecture we will study a type of signal whose waveform looks like a ramp, and because of this reason we call this signal unit ramp signal. A unit ramp signal is represented by RT, and it is equal to 0 when time t is less than 0, and it is equal to t when time t is greater than equal to 0. And you can see when time t is greater than equal to 0, RT is simply a straight line. RT is equal to t, which is the equation of straight line with slope equal to 1 and intercept equal to 0. We already know equation of a straight line is equal to y equal to mx plus c. M is equal to 1, c is equal to 0, so y is simply equal to x. In this case, y is equal to RT, so RT is equal to x and x is equal to t. So you can see RT is equal to t when time t is greater than equal to 0, and we will have a straight line passing through the origin because intercept is equal to 0 and making 45 degrees with the time axis. So let's plot the waveform of unit ramp signal RT when time t is greater than 0 or equal to 0. RT is simply equal to t, and when time t is less than 0, RT is equal to 0. The angle is 45 degrees, or you can say slope is equal to 1 because slope is equal to tan 45 degrees. Now we will discuss the properties of unit ramp signal. In the first property, we will find out relation between a unit ramp signal and a unit step signal. If you integrate the unit step signal, you will have the unit ramp signal. I will integrate the unit step signal from minus infinity to t, and we already know from minus infinity to 0, unit step function is equal to 0. So integration of 0 plus from 0 to t, considering t is greater than 0, we have 1 d tau. After performing the integration, you will have t, or we can write t multiplied with 1, and 1 is equal to ut. So t ut is RT. So integrating unit step function, we will have unit ramp function, or we can say differentiating unit ramp function, we will have the unit step function. So this is all for property number 1. Now we will move to property number 2. In property number 2, we will find whether unit ramp function is even function or odd function. We will find whether unit ramp function is even function or odd function, and for this purpose I will find the plot of r minus t, and to obtain the plot of r minus t, we only have to fold the plot of RT about the y-axis. So we have this plot, and you can see RT and r minus t are not same. RT is not equal to r minus t, so we can say that RT is not an even signal. Let's find out whether RT is an odd signal or not. To find out whether it is odd signal or not, I will plot the waveform of minus r minus t, and to obtain the plot I will fold the plot of r minus t about the time axis. So this is the plot of minus r minus t, and when you compare this plot with the plot of RT, you will find they are not same. So RT is not equal to minus r minus t, and this is the condition of odd signals. So unit ramp signal is not an odd signal. Let's move to property number 3. In the third property, we will find whether the unit ramp signal is power signal or energy signal, and for this purpose I will calculate the average power P. Limit t tends to infinity 1 by 2t inside the bracket integration from minus t to 0 rt is equal to 0 plus integration from 0 to t rt is equal to t and mod rt square is t square. So performing the integration and putting the upper and lower limits will give us t cube by 3. So we have limit t tends to infinity t square by 6, and when you put t equal to infinity you will have infinity. So the average power P is equal to infinity. Now we will calculate the total energy E, integration from minus infinity to infinity mod r t square dt from minus infinity to 0 mod rt square is 0, from 0 to infinity mod rt square is t square, and performing the integration we will have t cube by 3. The lower limit is 0, the upper limit is infinity. Infinity minus 0 is equal to infinity, so the total energy is also equal to infinity, and we can say that the unit ramp signal is neither power signal nor the energy signal. So this is all for this lecture. If you have any doubt you may ask in the comment section. I will end this lecture here. See you in the next one.